Okay, now we are in the final part of our chapter 3. So in here we will go through it. So actually our chapter 3 is all about interpolations, where we learned Lagrange interpolation, forward, backward methods and all, as well as extrapolations. Now we have started our inverse interpolations, as well as error in interpolation will be your reference, okay, for the time. And also so in our last lectures, we have started to define the interpolations and things, as well as we have seen our interpolation methods for the equal, equal interval x values, okay, as well as what if it is unequal intervals. We also have to also have a method which calls Lagrange interpolation polynomial. So in our last lecture, we have seen go through according to the Lagrangian, as well as we have seen some notes around SSN uniqueness problem. And also I have explained you one questions, I guess. All the other rest of the questions are your homework quizzes, which was in our homework quiz number 6. I have sent you all these notes as well as the homework quiz, so you can go through that one. Also, yeah, we have started our inverse interpolation. So I will, these are the notes I have already given you. Okay, so I will start where I have stopped. Okay, so I in the last lecture I have explained you the interpolation, inverse interpolation methods. There we're gonna see two different methods. First one we called as the iterative method, which is regarding the Newton-Gregory forward difference interpolation formula. Okay, so I show you the method how we can transform our Newton-Gregory formula to our desired formula of iterative formula. So which was first of all we have transformed our p, the value of second one. Using that we have derived about what is p. P is equal to yp minus y naught. So you have to know the forward difference method, which is regarding the y naught value. So in our equation I have put f of a. You must know, isn't it? A is our first interval, B is our, A plus NH is our last interval point. Okay, so for the f of A, I have put here y of naught. Okay, so you have to know how to distinguish the equations. So if you keep this one in this side, you have to take all the other terms that side, and I need to divide it by 1 over delta y naught. Okay, so that's what's happening here. So for the first value, I'm taking as the P1. Okay, so and also we are neglecting, so it should be P. Okay, yeah. There's a typo error. So this one should be P. Okay, not a P1. Okay, in this equation, we are neglecting the second as well as the highest order. So this is our second order. So I'm neglecting, and all these, whatever comes next to it, I'm neglecting. So I will end up like this. Okay, so that's what we are taking as a P1. Okay, this is our first approximation to the P. Okay, similarly, if you wanted to go to the next one, because iteration means what? From 1 to 1, you have to go to reach our desired point. Okay, so in our Newton-Gregory formula, we have found yp. Okay, but here we are doing our inverse. Okay, in the inverse sense, there they will give you the p. You have to find the p value using the value, the x of n, whatever the values you need to find, they will give you. Okay, so from that you have to find out what is the p. Okay, then you need to construct the table, and then using this everything, p value as well as delta y naught, delta squared y naught, all these value you have to find the yp. That is our actual process in our Newton-Gregory forward difference interpolation method. But here we are finding the inverse, isn't it? Inverse of Newton-Gregory forward difference method, which called as the iterative method. Okay, iterative method. And that's so in the exam also they will ask you to find using the iterative method, find this one. But you have to know what you are doing in the iterative method. Okay, sometimes they may give inverse Newton-Gregory formula. Okay, so according to the question, you have to know which it is talking about. Okay, so next one, after finding the P1, they are to get the P2. Okay, because it is from P1 to P2. Okay, P2 to P3. So we have to go to approach to the point where what we have to find. Okay, so in order to get the second approximation, what they are doing is they are taking up to the second this equation. Okay, so a second. Okay, so in this our original Newton-Gregory equations. Okay, so they are taking up to the second second order one, and then from there they are taking the P. So you have to know, only thing is if you keep so here only I can find the P, no? So they are keeping this one and taking this value and this value this side. Okay, and then for the P2 they are approximating wherever the P comes, they put our earlier known P1. Okay, so from this we have find the P1. The next step they are using that P1 to find the P2. Okay, so still the P, but we don't know about the P, so they are finding the P2. Okay, P2 they put the P1 earlier value, and then yeah. So similarly they are continuing. Okay, what if, okay, give me a second. What if it is third order? Okay, in the third order approximation, we have to use up to the third point, isn't it? Up to this one. Okay, there also we need to keep the P and then take all the things this side. Okay, but here from P1 to we have reached to the P2 terms. Okay, then to the P3, wherever the P comes, they use the P2 inside. Okay, actually, I think I didn't mention you. Okay, forward interpolations, you may have seen in later part, forward, forward difference method. They also told us, give me a second. Okay, let's start. In the forward difference, okay, you may seen in some book it called as the explicit, okay, explicit method. So explicit method. If it is backward, they say implicit method. Implicit method. So no, you don't need this one here, but I'm telling wherever you find you may need it. No. So forward difference we call as the explicit method. Backward we call as the backward we call as the implicit method. Okay. The explicit method, it says, okay, if you wanted to find the new value, okay, for example, P2, you have to use the earlier known value. Okay, so from this equation we have find P1 now. Then we are using that P1 to find the P2. Then P1 and P2 we know. Then we are using P2 to get the P3. Okay, so this means the explicit means the new value can be found from the earlier known values. Okay, known values. So already known values. But in the sense of explicit method, you may wonder, and in our backward also we say, for example, y, what is yn? Okay, in the backward, backward difference, what is the yn? Can you give me this one? You remember what is backward difference of yn? Can you give the general equation of yn? Okay. That's the others. Only one answering. I want most people to answer, no? Yes, you are correct. What about the other? What is the general equation of yn in the backward? Okay. So in the forward in the sense. So if you ask yn, okay, what will be the yn? So you have, if you say, let's say yn plus 1, okay, you have to take, what is the yn plus 1 in the back forward? Okay, let's say yn, okay. If it is yn, we have to go to the yn minus 1, isn't it? Is that correct? Sorry, this should be yn plus 1 minus yn, okay? Sorry. Is that correct? Give me a second. Yn plus 1 is equal to y next one, isn't it? So if you want, for example, this point is y0, okay? This point is y1. So if you wanted to take the delta y, okay, y0 is equal to y1 minus y0, isn't it? So it means, yes, okay, yn is equal to yn plus 1 minus yn, okay? So it says, is that, so in here also, this one we are saying yn minus 1. So correct? Yeah. From the same value. So what about the backward yn plus 1? Backward yn plus 1? Backward, okay. Yn plus 1 minus yn. Okay, good. So what is that says is, in the backward, still we don't know this one, no? We still don't know this. But in the equation also, we have that same unknown, no? Still we don't know, unknown. Okay. This, again, the calculation also, we are using that unknown, and we can rearrange and we can find something. Okay. So if you are using again the unknown in our process, okay, which called as the implicit, okay, it has some extra work. Okay. So explicit work is a little bit easier than the implicit work. Okay. This is extra thing. You don't need to confuse yourself, but the thing is, okay, so we have to use the earlier unknown also into this process of backward. Okay, that's why okay, so this comes. Okay, but yeah, in the explicit case, okay, so now here we are considering only the explicit case now. So in the explicit case, keep in mind we are dealing with the known values. So from this we have find from this yp and y0, we have found the p1. Then for the process of p2, we are using the p1 known values. Already we have calculated now. For example, let's say p1 is equal to 2. Then I can use here now 2 like that. So the known value comes for the process of second one. And again for the third one, we are transforming all the p as the earlier one, p2. Okay, still it's known. From this we know. Okay, so I can find the p3. Okay, so it's for the third approximation I use like that. So whatever the order, still nth order, you can use the nth process. Okay, where you have to use the, if it is a nth, you have to use here pn minus 1. Okay, so when we are doing example, you will find. So it goes. Okay, this process continue till desired accuracy. Okay, for example, they will ask you what is the some values up to, let's say, p approximately this way, approximately 1 decimal point or something like that. Okay, they will ask you some accuracy. Okay, on that sense you have to go up to it. Okay, So this process is called as the iterative method. Okay, it's called as the iterative method. Okay. So let's do one of the examples so you will understand. So take your homework quiz number 6. So question number 5 to 7, it's regarding this iterative method. Okay, so let me. So take down the question number 5 in our quiz number 6. Okay. So in this quiz, we can see Lagrange interpolation polynomial as well as inverse Lagrange interpolation questions. Okay. So let's begin. Okay, this one, 5th question. So let's start our 5th question so you will understand some regarding the iterative method. Okay. So the question says is find the value of x. Okay. So here in the earlier question, if it is sorry, it should be in inverse interpolation, not Lagrange. Okay. So in this section, we also have iterative method as well as inverse Lagrange method. So cut this one. Okay. So iterative method, we have the question 5 to 7. Okay. So they say find the value of x, isn't it? So if they ask you to find the y value or anything, you have to go for the normal process. If they ask you the x values, you have to use the inverse method. It means iterative method. Okay. For y is equal to 3000 from the following data using iterative method. Okay. So they already asked you. So you have to know, okay, this is regarding the inverse process. Okay. So see here, if y is equal to 3000, what is the x value? This is the question. But in this table, we have 10, 15, 24, 1754, some numbers, but between this only we have, 3000, isn't it? So somewhere 15 to 20, we will find the answers. Okay. So let's check it. But before that, we have to create what? So from this data, so first of all, go to the iterative method. First of all, you use the Newton-Grigori forward formula to formulate it. Okay, so they didn't give you anything. They just gave you some data. Okay, using this data, you know how to create a interpolation, polynomial of Newton-Grigori forward formula. Okay, and then after that, you have to use your process of finding the P. Okay, onto that X. Then using the P, we can find the X. Okay, so X is the question. So from this, you can find the P. Then with the equation of X, you can find the, using this P and all, you can find the final answer. Okay. Okay, I'll show you this process, but the rest of the question, you have to do it. Let's take me the whiteboard. Okay. So first of all, we have to make a forward table, Newton forwards table. So first X value and Y value, that's all we have. So for the 10, they say 1754. For the 15, they say 2648. So this is solutions, okay? And then for the 20, they say 3564, okay? So as I said you, we need to create a forward table with some process. Okay. So first of all, as I said to you, let's begin with the index number 0, 1, 2. Okay. Then we have to create delta y naught or delta y or something and delta squared y. Okay. We can go, since there are 3 only, I don't think so. We go like that. Okay. So we know this is a forward, no? So forward means we know what is delta. This will be my y naught. This will be my y1, y2. So this will be actually y naught. Okay. So what is y naught? Can you do this? I need your answers. Okay. And then you find the, I think that's all. Only these values you have to find. Okay. Only 3 values, no? Okay. Then also write, what is P1? What is P2? it is P3. So if you can, you memorize it. Otherwise, it's better, I can tell you, it's better you to derive from our final answer. For example, actually, okay, finish up this one. I will explain. So, send me the answers. What is delta y naught? What is delta y1? And then delta squared y naught is what? I want everyone's answer. Otherwise, I will call your number. So if you answer, it will be better. Okay, I got one answer. How about? Only 2 people are here. There are 98 people here. I need at least 5 to 10 answer. Otherwise, I won't continue. So what is this? You just taking this minus this? No. So is that the big thing? Why you all are silent? I want at least 10 people answer. Otherwise, I will call your name for as an attendance and wasting my time, no? So you better work on it. And others, can you write down the full form of the Newton-Gregory formula, then write the what is P formula, and then from that what is P1, then find the P1, and then using the P1 find the P2. I think you don't need to go much. P2 is enough. Can you try these things? Okay, I'm getting some answers. Let me check. Why 893? Is that 3? No. 8 minus 4 will be 4, no? Please use calculator. It's better you to use calculator, okay? I know you can subtract yourself, but in this course, you better use everything as a calculator. So rather than, because this is something like minute thing we are considering, okay? So in the answer also, for example, let's say my answer will be 89.89425 something, okay? So the answer can be given as plus or minus 0.005 or 001, something like that, okay? So you can get the answer 84.24 or 89.4.26, okay? This answer only the correct answer. So if you do that, if you make a mistake here, it will be ruin all your answers. So you will get 0 marks or something less marks, okay? So you better use the calculator for all the calculation for this course, okay? So other course, I don't think so. You can use anything, but the better way to use calculator here. Yeah, okay, good. So how about what is the, write down the full form of the equation, Newton-Gregory equation. Okay, so I don't need to copy. I hope you can write what is yp is equal to y naught something. Okay. Okay, so if our meeting end, you can join again. So what is p? P also we have derived 1 over delta y naught. Okay, first of all, you don't, write up to third order. Okay, hopefully, for the time think in the examinations, they will ask you something around third approximation or fourth. Okay, so you better write up to that one. Okay, p minus 1, p minus 2 divided by 3 factorial times delta cube y naught. Okay, that's something. Okay, so what is p1? So after this, you write down neglecting the second and higher orders. So p1 will be this one. Okay, so you have to write something regarding what is the process you are doing. Okay, example, neglecting neglecting the second and the higher order, we have P is equal to, P1 is equal to 1 over delta y naught, yp minus y naught. Okay. So in here, okay, delta y naught, what is that? We got 894. What is our yp minus y naught? So actually, yeah, what is yp? Tell me. Y naught, I know, 1754. What about the yp? Anyone? What do you think? Read the question again. Okay, yes, the question is the yp, no? So on that, whatever the p value, my yp will be 3000. Okay, so find the x value, that's the question. So whatever the question is the yp. Okay, okay, good. And then if you do that, what you'll get, p1 is equal to something, don't, round off for now. Okay, for at least, for they say in the question as well, they say to correct to the 1 decimal place. So you have to write up to the second decimal point for the initial, initial calculation. We have to keep until second or third decimal point. Okay, after last point only you have to make the correct to 1 decimal place. Okay, so if you say so, what will be that? Yes, okay, something like 39373, something like that, isn't it? So you can write up to 3 or 4, okay, or up to 2 or 3, okay, so that's fine. So this is my, so I can write something 1.39, okay, or 3, because 9 is there now, so you can better keep something regarding that, okay. How about the P2? So write the first, first of all, write the equation y naught and then yp minus y naught minus p1 times p1 minus 1. So this calculation is the must because it is coming again, no? So if you make any mistake here or earlier part, you will ruin your answers, okay? So anyway, you will lose your marks. So better you will be careful, okay? This one y naught. So only thing is substituting, no? So can you do that? Use the calculator and find the value, please. We can write this one in a bracket. Okay. Did you find the answer? Okay. Yeah, 1.387. Yeah. Okay, good. Okay. So we don't need to go for third one because, from this we're gonna find our x, p, and then x. Okay. So I will use the window. Okay. Now, so what is actually So whatever the P2, I am approximating as P, which is equal to 1.387. Okay, so I'm taking that P as our last point. Okay, since why I stopped here, because if you go for P3, okay, you need Y cube, why not? No, but in this table we don't have, isn't it? So if you are having in the other examples, if you have delta 3, why not? Delta 4, why not? So you have to go up to that, okay, P3, P4, something like that. So here we don't need to, because we are ending up to delta squared, why not? Okay. So we are taking that one as approximately of P value, okay. So that is our P. We have find our P, okay. That's the process. Now, what is X actually? From the X naught, so can you write the equation of what is X? So any value X can be written as using X naught. What I'm meaning is, see here, this is our X naught, this is our X1, this is our X2, up to it's going. So the difference we called as a H, isn't it? So we are here iterative method, we are taking all the differences are equal. Okay. So what if, for example, Xi, this is my Xi, okay. So to reach this Xi from here, how I supposed to write? For example, Xi can be X naught to, how many time I need to take H? For example, I time I need to take H, isn't it? Am I right? So this 1H, 2H, 3H, 4H, up to I time. Okay. If it's, let's say, Xn, I need to go X naught to NH. Okay. So hope you remember that one. Okay. But here we are transforming that N as a P, no? pH, isn't it? I think Xn is equal to, what is that? Can you write me that, the Grigori? When you are deriving, we had that one, no? Can you check the notes? Yeah, something like, I think I wrote like A plus NH plus pH, isn't it? So whatever the A plus NH, we are taking as X naught. We are going from X naught to H, the P times, okay? So it means, the color. So final process is, after finding the P, you have to know X equal to X naught plus pH, okay? So I know my X naught. What is my X naught?